Good day, and you are welcome to our next class. Circle. We all know circle. This is circle. If they say that a circle is the locus of a point. Locus of a point means set of points which moves in such a way that its distance from a fixed point. That fixed point from a fixed point, it moves in such a way that this is set of points that are moving. It moves in such a way that its distance from a fixed point is always equidistant to any other point on it. This any other point, that is from the distance from this place to this place, or from this place to this place, from or to this place, always equal to each other. That is what they mean by equidistant to each other. And this distance is what we mean by radius of the circle. Radius of the circle. And all these points, which is called any other point, we call it circumference of the circle. Now, we say that a circle is an example of a conic section, and it's a special case of ellipse. What do they mean by a conic section? If they say that conic section, we simply say that conic section is the intersection of a cone and a plane. So from the conic section, we normally have what we call ellipse. We normally have what we call parabola, and we normally have what we call hyperbola. So these are the three conic sections. So this ellipse is an example of this ellipse is a special case of a circle. Circle is a special case of this ellipse, which looks like this. But in circle, all the sides are equal. We call this one radius, but in ellipse we don't call this thing radius, but it has like an oval shape. Now let's move to equation of a circle. This is a circle. This is the center of the circle, which I label as A, B. This is our A here, this is our B, and this one is X, this is Y. So we label this as A, B, and this X, this is A, and Y and B. So when we join it, we have all this. So if you use Pythagoras theorem, it will be square root d square plus d square is equal to, don't forget that here I said the distance from this center to this place is the radius. You can see this is the center here to this place. That is our radius there. So in that case, we have using Pythagoras theorem, our equation of a circle becomes x minus a square plus y minus b square equal to r square. So this is what we call equation of a circle centered at point A, B. So this is what we mean by equation of a circle. And when the center is now at origin, that is at 0, 0, when the center is at origin, something like this. Let's say this is a circle, this is center. So the equation, in that case, this A and B will be 0. Instead of A and B, we will be having 0, 0. So our answer is just x squared, because it will be 0. It will be x squared plus y squared equal to r squared. So this is equation of a circle centered at this is centered at origin. Origin there simply means 0, 0. So these are the two equations of circle. This is centered at point A, B, while this one is centered at origin. This one is centered at origin. This one is centered at point A, B. Now let's take example. Example 1. Find the equation of a circle. Equation of a circle of radius 5 and centered at point 3 minus 3, 6. In this place, our radius is 5 and our center, which is A, B, is minus 3 comma 6. So that means this is our A, this is our B. It has been given. Then we use the formula which says s minus a squared plus y minus b squared equal to r squared. So we have s minus our A. Our A is minus 3. So it will make this place to be plus all squared plus y minus b. Our b is 6 all square equal to r square. Our r is 5, so equal to 5 square. Then we now need to expand this to get our answer. Expanding this one, we are going to have s square plus 6s plus 9. And expanding this one, we are going to have y squared minus 12y plus 36 equal to 5 square is 25. Now, we have expanded the expression. To now get the final expression of a circle, how do we normally write circle? You take the square first, the square of s and square of y. Secondly, you take the linear, the x and the y. So we take plus s minus this. Now, the last one is we take the constant. The constant will now be 9 plus 36 minus 25. And 9 plus 36 is 45. Then if the 25 comes in, it will be 45 minus 25. And that will be 20 is equal to 0. So this is how we write equation of a circle. So it will always look like this: s squared plus y squared plus 2gs plus 2fy plus constant, we don't know it, equal to 0. It will always look like something of this nature. So we are coming there. Now let's take another example. Example 2. Find the equation of a circle centered at 3.4, 3,4 and passes through 6,8. Now, we have been given the center A, B, which is the center. They say centered at this 3,4. We need two things. We need the center and we need the radius. We have known the center, but we don't know the radius. If you consider what the equation says, the equation says it has center at 3,4 and it passes through a point 6,8. The equation says it passes through point 6,8 and passes through the point 6,8. So let us just assume that the 6,8 is here. So if you want to get radius, we have said that the distance from this center to any point here is the radius. So in that case, how do you now find the radius? Radius, we use distance between 2 points. We use distance between 2 points to get our radius. So in that case, we get our radius by using distance between these 2 points. In this case, our r is, if you still remember, square root of s2 minus s1 square plus y2 minus y1 square to get the distance between these 2 points. And that will be 6 minus 3 square, 6 minus 3 square plus 8 minus 4 square, 8 minus 4 squared. Then our r is equal to, this will give me 6 minus 3 is 3. Then 3 square is 9. This is 4. 4 square is 16. Then it will be 5 because this is 25. Square root of 16. The square root of 25 is 5. So we have known the radius. So I can now make use of this formula. So our answer will now be, the equation will now be equal to s minus a square plus y minus b square. Our a is 3 plus y minus b square. Our b is 4 all squared is equal to r squared. Our r here is 5, which is 5 squared. Now we now need to expand this. Expanding this one will give me s squared minus 6s plus 9. If you expand this, it will give you y squared minus 8y plus 16 equal to 25. Now, how do we write it? It must be in this format. S squared first, followed by y squared, followed by the coefficient of s, the x, linear, and the y linear followed by y followed by the constant. 9 plus 16 is 25. If you bring 25 in, it will become minus 25. So that will be 0. So there's no constant there. So we say equal to 0. So this is the required equation of circle. This is another formula for finding equation of a circle. The other one is equation of a circle giving radius and center of the circle. But here we are dealing with equation of a circle through the endpoints of diameter. The diameter divides circle into two equal parts, or it's a straight line that passes through the center. This is center here, this is diameter. We are giving endpoint here, we are giving endpoint here. Here we have s1, y1 and s2, y2. This point s1, y1. You know, this place is 90 degrees. That is, if you look at circle theorem, which says angle in a semicircle is perpendicular. That is 90 degrees. So in this case, I can say that the distance between these 2 points and the distance between these two lines here are perpendicular to each other. So that is, the distance between these two lines, this one and this one, they are perpendicular to each other. Or simply, we can say that since this line is perpendicular to this line, definitely their gradient will be equal to -1, as you have said before. And what's the gradient of this line? The gradient of this line is y minus y2 over s minus s2. That's the gradient of this line. And the gradient of this line is y minus y1 over s minus s1. Everything must be equal to -1 since the lines are perpendicular to each other. So if you simplify this, so the equation becomes s minus s1 into s minus s2 plus y minus y1 y minus y2 equal to 0. So this is called equation of circle through the endpoint diameter. When the endpoint diameter is given, we make use of this formula. So the formula again is simple to memorize: x minus s1 x minus s2 plus y minus y1 y minus y2 equal to 0. So this is another formula for finding equation of a circle when the endpoint diameter are given. Another example, find the equation of a circle whose endpoints of the diameter are given as this. So in this case now, this is our s1 y1 s2 y2. So if we use the formula is s minus s1. Our s1 is 6 into s minus s2. Our s2 is 2 plus y minus y1. Our y1 is 5 into y minus y2. Our y2 is 3 equal to 0. Now expanding this one will give me s squared minus 8s plus 16. Expanding this one will give me y squared minus 8y plus 15 equal to 0. So sorry, this one is 8. 2 times this is 8 plus 8. From that place, we have 8 s squared. We take s squared first, followed by y squared, followed by this 8x as usual, followed by this 8y, and followed by the constant, which is c. 8 plus 15, 23 equal to 0. So this is the required equation of the circle. So you now see that it will always look, the equation of circle will always look like s squared plus y squared plus 2gs plus 2fy plus c equal to 0. It will always look like this. It will lead us to general form of equation of a circle. This is general form. Now let's move to general form of equation of a circle. General form of equation of a circle is given as this. So we recall this, that this is equation of circle. Now if you expand this first one, you will get this. if you expand this one, you will get this. So go and learn how to do that. Equal to r square. Now, as usual, how do we express circle? We write x square first, y square. The next one is the coefficient of s, and that of y, the expression of y, and the constant. The constants are this: a squared, b squared. If you bring r in, we have minus r square equal to 0. So you will now see that it looks like what I've been given before. So this one looks like there's 2 here, 2fx. We generalize it. That f is representing minus a plus 2gy plus the whole of this is c equal to 0. So this is general form of equation of circle, where this f is equal to minus a, or a is equal to minus f, where this g is equal to minus b, or b is equal to minus g. Also, where this c, we are representing everything here by c. C is a square plus b square minus r square. So if you make this r square the zero formula, r square will be equal to a square plus b square minus c. Then making r the zero formula, our r is square root of a square minus this. So from that place, you can now see that the center of the circle is since our b is this and our a is this, so we can say that the center of the circle is minus f minus g. Also, the radius of the circle is a square plus b square minus c. As I've used f here, some textbook will use g instead of f. Are you with me? This instead of f here, they will use g. Instead of g here, they will use f. But let me just use g there in order so that if you are reading textbook and you see something like that, you may think is different. So they are the same thing. So okay, let me change this place to g and let me change this place to f. So definitely this one too will change. This is a, this is b, this is a, and the rest did not change except this minus g minus a. That will be the center of the circle. So general equation of a circle is this. Is general equation of a circle: x squared plus y squared plus 2gs plus 2fy plus c equal to 0. So let's take example. Example 4. We want to find the radius and coordinate of the center of this circle. Before we have been given radius and center to find the equation of a circle. Now we have given equation of a circle here. We have been given equation of a circle here, and we want to find the radius and center from it. So it's just like we are now moving back. That is one of the applications of the general form of a circle. Let's recall that general form of a circle is written as this: x squared plus y squared plus 2gx plus 2fy plus c is equal to 0. Now, immediately we can know our g by saying that 2g is the coefficient of s. We equate it. 2g is this, is minus 10. Also 2f is 8. 2f is 8. Then c, if you compare it, you only need to compare it. C is equal to minus 59. You can see 2g is beside x, so we equate it to the number or any number that is beside x. The same thing goes to y, and the constant is here. From this place, our g is minus 5. Our f is 4. Our c is still minus 59. Then what is our center? Center we have been given in the formula. The center is this minus g comma minus f. In that case, the center will now be equal to our g. Our g is minus 5 already, so minus g will now be 5. Our f is 4, so minus f is minus 4. Then what will be our radius? Our radius is this g square plus f square minus c. So that is the one we put here, a square plus b square minus c. That a square and g square are the same thing. Because of that square, they will become the same. So instead of saying a square, because we are not using a and b again, we just use g and f. G square and f square, they won't change, and which I have written in this place. In that case, this is our g square, this is our f square minus c. Our minus c has become plus 59 because c is minus already. So in that case, we are going to have square root of 100, which is r is 10. Now, another way by which we can solve this, we are given s squared plus y squared minus 10 plus this. So we need to write out s separately and y separately. Then we take the constant to the other side. That's 59. We take it to the other side. From this place, we are going to have s minus 10. We apply this first two. You will need to apply what we call this quadratic formula. You apply it, the quadratic solution, and that is completing the square. How do you apply completing the square? This is 10. You look for coefficient of x, which is 10. Half of it, you square it. 5 square, if you can still remember. This is 8. Half of it is 4. We say square. Remember, we have added 5 square to this place. We have to add it in order not to be biased. The 4 square that we added to, we have to add the 2. So that in that place, we will have, our answer will become, this place is s minus 5 all square. This one will become y plus 4 all square equal to, this one is 100. But 100 is the same thing as 10 squared. So you now need to compare it with the formula that I gave before, which is this. Y minus b square is equal to r square. You will see that your a is 5. Your b here, if you compare, is minus 4. And your r is 10. So we have found that our center is a comma b. 5 comma minus 4. And our radius is 10. So that is another way of solving it. You will see that our center is this 5 comma 4, our radius is 10. I've written it for you here. That is the answer. And let's take another example. Another example. Find the equation of a circle that passes through this point, minus 2 comma minus 6, and this minus 6. If they say that an equation passes through a point, it simply means that the equation is satisfied by the point. Which means if you put s to be minus 2, put y to be minus 6, it will be true here. Now, anywhere from this point, anywhere I see s, I'll put it as minus 2, and minus 2 square is 4, minus 6 square is 36, plus 2g, our x is minus 2, plus 2f, our y is minus 6, plus c equal to 0. We know that this one is 40 already from that place, but there is minus here, there is minus here, to make this place to be plus and this place to be minus. If you take 40 to the other side, so we have 40 here. So let me call this equation 1. Also, from 5 comma minus 7. Anywhere I see s, I'll put it as 5, y as minus 7. So this is 25 plus 49. Y is 7. 7 squared is 49 plus 2g into 5 plus 2f into minus 7 plus c equal to 0. So you will observe that this plus this will be equal to 25 plus 49. 25 plus 49 will give me something, but let me take the letter first. This is 10g minus 14f plus this c equal to this one that we took to the other side. If you take it to the other side, we should have minus this is 74, equation 2. Finally, from 6 comma 0, put s to be 6, y to be 0. That will give me 36 plus 0 plus 2g into 6 plus 2f into 0 plus c equal to 0. So from this place, this will give me 12g plus c is equal to, when this 36 comes to the other side, we have minus 36. So this is equation 3. Now let's bring the 3 equations together. It will lead to simultaneous equation, which I believe you have done. Now, the work here, which I want you to now do as an assignment, is to now solve this equation simultaneously. That's your own work. 2f plus 0f plus c equal to minus 36. So you need to solve this. So you need to solve these 3 equations in order to get your answer. But when you solve it, you find out that g is minus 2, f is 3, and then c is minus 12. So this is an assignment for you, which must be submitted. So we have known the value of our g, f, and c. So since we have known the value of our g, f, and c, we need to substitute it here. So the equation of the circle is now y squared plus s squared plus 2gs, 2g. Our g is minus 2. It will just be minus 4s plus 2fy. Our f is 3. That is 6y plus c. Our c is minus 12 equal to 0. So this is the required equation of the circle. We now move to equation of tangent and normal to a circle. Now we move to equation of tangent and normal to a circle. You know, this is a circle. Any straight line that touches a circle at one point there, we call it tangent. That was what they mean by tangent. If they now say that normal, this normal, a straight line that is perpendicular to this tangent is what we call normal. If you have a straight line that is perpendicular to this tangent, so we call this one normal. This is what they mean by normal. Now, we are dealing with equation of circle centered at origin. We first talk about that. Equation of circle centered at origin. You know, we have been given that to be this. This equation of circle centered at origin. So equation of tangent to the circle is given as this. To the circle centered at origin is given as this. S times S1 plus Y times Y1 is equal to R squared. What is our S times S1? That is point of contact. This is our S1 times S1 comma Y1. Also, this is equation of normal. This is a formula. It's something we can prove using calculus. And if it is centered at point A comma B, then equation of circle is given as this. This S1 and Y1 is the point of contact. That is where that tangent line touches the circle. That is the meaning of the contact point, which is this S1 comma Y1. And this is equation of normal to circle when it is centered at any point A comma B. Let's take example on this. Find the equation of tangent and normal to this circle at this point. So this is our point S1 comma Y1. Now let us first write it out. s1 comma y1 is minus 1 comma minus 3. So for tangent, the formula of finding equation of tangent to circle is ss1, just like what I wrote the other time, equal to r squared. What's our s1? Our s1 is minus 1 plus y times our y1 is minus 3 equal to r squared. What's our r squared? R squared is our 10 here. The 10 that is here is our r squared. So from that place, we are going to have minus s minus 3y equal to 10. Or you take minus to the other side, we have s plus 3y equal to minus 10. So this is equation of tangent for normal. So we have been given normal to be s times y1 minus y times x1 equal to 0. This is it once again. So from that place, our y1 we have no need to be minus 3. This is our y1 minus y into x1. Our x1 has been known to be minus 1 equal to 0. So this is minus 1. So this one gives me minus 3s plus y equal to 0. Or we say that y minus 3s equal to 0. So this is the equation of normal to this circle. Let's consider another example. Second example, find the equation of tangent and normal to this circle at this point. When you are given this type of circle, it's simpler. It's not as simple as this one. This one is easy, but for this one, we need to apply the method that I showed you the other time. The first thing is, let me write out the circle. Let us first know our, for circle, y square and x square, their coefficient must be 1. In that case, I will divide both sides by 3, so that their coefficients must be 1. So this will be 8 over 3x minus, this is 6 over 3y minus 61 over 3 equal to 0. So that it looks like circle. If you now recall, if you remember what we just did, this is 2gs plus 2fy plus c is equal to 0. What we only need in this place is our g and our f. That is only what we need. When we have known our g, then we cannot go to tangent and normal. As usual, we have been doing that. We know that 2g will be coefficient of s, which is minus 8 over 3. Also 2f is minus 6 over 3, and minus 6 over 3 gives me 2. We don't need the c. You only need g and f. From this place, our g will be equal to minus 4 over 3, and our f is equal to minus 1. So since we have known that we cannot go to equation of tangent, for tangent, we have said the formula is xs1 plus yy1 plus g into s plus s1 plus f into y plus y1 plus c equal to 0. So from that place, we have known our c too. Our c is minus 61 over 3. Let's substitute everything we have. This is our x1. Our x1 is 4. Our y1 is 5. So from this place, we have s into 4. y1 is 5. Let's just put everything plus g. Our g is minus 4 over 3 into s plus s1, which is 4. And our f is minus 1 into y minus y into y plus y1. Our y1 is 5 plus c. Our c is minus 6 over 3 equal to 0. So you now observe that 6 over 3 is common at the denominator. Let's multiply both sides by 3. Sorry, 3 is common. In order to evaluate it, we multiply both sides by 3. If I multiply this one by 3, it will give me 12x. This one by 3, it will give me 15y. the 3, this one will be eliminated because of the 61 here, because of the 3 that we are using to multiply. It will be eliminated. What we are going to have left is minus 4 times s, that is minus 4s. Minus 4 times 4 is minus 16, and this is we use 3 to multiply this. Minus 3 times y, that is minus 3y. Minus 3 times 5, that is minus 15. Then the 3 will be eliminated there to remain 61 equal to 0. And simplifying will now give me, it will give me this when I simplify. That is that about that. The next one is for normal. We have known that normal is y minus y1 over s minus s1. You need to memorize all these formulas. When you don't know all these formulas, it will be very difficult for you to handle. Into the first one, this one is f plus y1, and this one is g plus s1. Now we have y minus y1. Our y1 in the question is 5. This is it here. Our x1 there is 4. Our f is minus 1 plus y1, which is 5. G, which is our minus 4 over 3, plus s1. Our s1 is 4. So this will give me 4 divided by, this should be 8 over 3. And 4 divided by 8 over 3 can be 4 times 3 over 8. This is 3 over 2. So we then need to cross multiply so that we have 2 into y minus 5 plus 3 into, equal to 3 into s minus 4. And simplifying will give me this. So this is our final answer. You should know how to do this. So this is our final answer for the question. So this is another question here. Find the equation of tangent and normal to this circle at this point. This is the solution. You can see the solution. So you practice it yourself. I don't need to explain. Just follow. So this is the solution. We have example here. At the intersection of this line and this circle, drawn are the tangents of the circle. Find the area of the triangle the intersection point forms with the tangent line, and also find the angle between the tangent lines. Before solving it, let me first explain what this question is saying. This is a circle. This is a line. This is a line. S minus 5y plus 6 is equal to 0. Let's assume. But they said that at the intersection of this line and this circle, these are their intersection. This place. Now this is the second point here. They said they are intersected. From this place, the question says drawn are tangents of the circle. So we don't know. They said they draw 2 tangents of this circle from this place. Definitely they will mean somewhere there. The first question now says, can we find the area of this triangle? This is the triangle. This is the adjacent line and the tangent lines. Also the angle between this place. So that is what we are looking for. If you have understood that, now let me now move to the question. Let me start the question. The line is x minus 5x y plus 6 equal to 0, and the circle is s squared plus y squared minus 4s plus 2y minus 8 equal to 0. The question says at the point of intersection. If they say that point of intersection, I have mentioned that before, simply means simultaneous equation. So that means we should solve these 2 equations simultaneously. And how do we solve it? You use substitution method. Make S0 formula from s minus 5y equal to 6 equal to 0. If you make s the same formula, s will be equal to 5y minus 6. Now let's substitute it here in this second equation. Anywhere I see s, I will use this. so that this one will become 5y minus 6 all squared plus y squared. Normally I didn't supposed to be doing this, but let me just do it. Minus 4x, our s is 5y minus 6 plus 2y minus 8 equal to 0. Now we need to evaluate this by expanding it. Let's expand it. This will give me 25y squared minus 60y plus 36 plus this y squared minus this one is 20y plus 24 plus 2y minus 8 equal to 0. We simplify further, we should have y squared minus 3y plus 2 equal to 0. So this one leads to quadratic equation. And if you solve this quadratic equation, we are going to have y is equal to 1 or y is equal to 2. When you are solving it, you must not jump this step. You have to show me why this thing becomes this when you solve the quadratic equation. So we have found out that y is equal to 1 or y is equal to 2. Now we come to this place. From x is equal to 5y minus 6, that is from this place, we need to bring back our y to get our x. If y is equal to 1, well, our x is equal to 5 into 1 minus 6, which is equal to minus 1. So in that case, the point of intersection there is minus 1 comma 1, that is s comma y. Also, if y is equal to 2, our s there is 5 times 2 minus 6. And 5 times 2 minus 6 will give me 4. In that case, I can write that as 4 comma 2. So let me say that this is the point A and this is the point B. So that means this is point minus 1 comma 1 and this is point 4 comma 2. We need to know this point. The first question says, drawn are tangents of this circle at this point. At this point, at these 2 points, we need to find the tangent line. Now we are now finding the tangent of the circle. Now at point, the first one, let's take the first point, because the question says they draw a tangent of this point. Tangent at this point, the tangent of the circle. What's the circle? This is a circle. This is now where you need to know the tangent of the circle very well. Minus 4s plus 2y minus 8 equal to 0. Tangent of the circle, we still remember, ss1 plus yy1 minus 4 into plus g into s plus s1 plus f into y plus y1 plus c equal to 0. Now if I use that, our answer is s into our s1 is minus 1, our y1 is 1. What is our g? 2g is equal to minus 4, 2f is equal to 2, so our g is minus 2. So we have minus 2 into s plus s1. Our s1 is minus 1. If you make f the same formula here, f is 1. 1 into y plus our y1 is 1. And our c is here, which is minus 8 equal to 0. And this one will give me minus x plus y minus 2x plus 2. This one plus y plus 1 minus 8 equal to 0. When we finish simplifying, so we should have 2y minus 3s equal to 5. Let me call it equation 1. So this is the equation of tangent at this point. Now at the second point, which is 4, 2, I will still use this formula. The formula is s into s1, which is 4, plus y into y1, which is 2, plus g. Our g is still the same thing, minus 2 into s plus, this is our s1, this is our y1, plus f, which is 1, into y plus y1. Our y1 is 2 here. We still have plus c. Our c is still minus 8 equal to 0. So this will give me 4x plus 2y minus 2s minus 8 plus y plus 2 minus 8 equal to 0. So on simplifying this one now, when we simplify it, so we should have 3y plus 2s equal to 14. This is the, let me say this is equation 2. This equation simply means the tangent at 4,2. So we draw it out. The tangent at this point has given me 2y minus 3s is equal to 5, while this equation of this line has given me 3y plus 2s is equal to 14. We need to know this point too, point C. What will be point C? Point C will be point of intersection of this thing. Now, let me go to the first one. We need to know point C. C means point of intersection between the tangent lines. And what are the tangent lines? 2y minus 3s is equal to 5. 3y plus 2s is equal to 14. These are the tangent lines. Point of intersection, that is, we solve these things simultaneously. To get our x and y. The value of x and y is the point of intersection, which is our point C here. Now, let us now solve these two equations simultaneously. But I don't need to teach you, but you don't need to jump the step. Don't jump. So don't jump, you solve the simultaneous equation. When you solve the simultaneous equation, you see that s is 1, y is 4. So in that case, our C point of intersection is 1, 4. So this is point of intersection. So we have known point 1, 4 here. Then the question says we should find area of triangle. Therefore, if you still remember, area is, so we still remember this is our area. This is the formula of finding the area. So that is our point A is minus 1, 1. This is our s1, y1. Point B is 4, 2, s2, y2. And our point C is 1, 4. That is s3, y3. So we are following the question. The question says you should find the area of the triangle. Since you have known the third point, I cannot find the area of this triangle using this formula. And when I substitute everything, I'm going to have area is equal to half. So you should know how to, we have done this before. Half into minus 1 into 2 minus 4 plus 4 into 4 minus 1 plus 1 into 1 minus 2. That is, if you substitute all this s1, s2, s3 inside this place, you are going to arrive at this. And arriving at that, this will give me half into everything will give me 13. And half times 13 will just be 6.5. We say unit square. So that is that about that. The second question says we should find the angle between the tangent lines. The angle between these 2 points. What are the tangent lines? The tangent lines. Tangent lines, and to know the angle between them, you only need to make y the same formula to know the gradient, as you have done before, angle between 2 lines, and that will give me 3s over 2 plus 5 over 2. Therefore, our first gradient is 3 over 2. Also here, making y the same formula, we have minus 2 over 3s plus 14 over 3. Our gradient is minus 2 over 3. So this is our M2, this is our M1. If you can still recall, you recall that the angle between the lines is arctan m1 minus n2 over 1 plus m1 m2, and that will give me arctan m1. Our m1 is 3 over 2 minus this is our m2, that will be plus 2 over 3 divided by 1 plus m1 m2. What's our m1 m2 here? 3 over 2 times minus 2 over 3. So this will give me arctan 3 times 3, 9. That is 13 over 6 divided by, this will give me 0. The whole denominator will give me 0. That will be arctan. This over 0 will give me infinity. And arctan infinity is simply 90 degrees. So that means the angle between them is 90 degrees. And that is that about that. A line and a circle. Let's consider this line, this circle and a line. Line connecting to this can be in 3 forms. It can be a chord like this that is inside the circle. It can be a tangent, that is, it touches this place, and also it can be outside. But whatever the case may be, this line to this line from the center of a circle, it will always be perpendicular. They are right angle. So that is a connection between a line. So this one is a tangent. It's in 3 forms when we have a line and a circle. This one is a chord. This one is a tangent. Why this one is just an ordinary line? It's just a, let me say, it's just a perpendicular line that does not touch the circle. So this one touches the circle in 2 places. Tangent to touch the circle in 1 place. Now, if you now want to find the distance from the center of a circle to any line, to find the distance of the center of a circle to a perpendicular line, as you have seen here, that even if we draw a line from the center of a circle to all this line, it will be perpendicular to them. So we assume that the line is of the form ax plus by plus c equal to 0. We have given this before. The distance is still as1 plus by1 plus c. That is perpendicular distance. But this one is from the center. So this is the formula, we have given it before. But the question is that what is our S1 and Y1? S1 and Y1 here is representing the center of the circle. It's very easy when the circle is at origin, because S1 and Y1 will just be 0. Y, A and B are the coefficients of S and Y in that line. Let's take example. Find the perpendicular distance between this line and the center of this circle. So we only need to know the center of the circle in order to know our S1 and Y1. That is what this S and Y will represent. We need to know the center of this circle. And as usual, if you use the formula, we know that 2g is equal to minus 4. 2f is equal to 4. Then our g is minus 2. And our f is 2. Therefore, if you remember the center will be minus g comma minus f. That is 2 comma minus 2. So that will be the center of the circle. So we can now make use of this formula. Our answer is absolute value of as plus by plus c over root of a square plus b square. A square plus b square. We are dealing with s plus 5y plus 16. S plus 5y plus 16 equal to 0. And the center has been given to be this. Therefore, the distance will now become a. We just write this out again. We now substitute s to be 2, y to be minus 2. This will be 2 plus 5 into minus 2 plus 16 over square root of a square. The coefficient of s here is 1. 1 square plus square root of b square, which is 5 square. And this one will give me 8 over square root of 26. So that will be the answer. So 8 over square root of 26 is the distance, perpendicular distance between this line and the center of this circle. At this question, the question says find the equation of a circle centered at this point and touches this line. Since this is the center, at this point 1, 20, and they say that it touches this line. Touches means it has just one point. How do we now find the radius? Radius is just the distance between the center here and this line. It's a perpendicular line by circle theorem. It's a perpendicular line. Then I will now find the radius. This is the formula I will use for the radius. The center is given already. So the radius will now become 8 into, this will be our x, plus 5 into 20 minus 19 over square root of a square plus b square. That is, this is our a, this is our b. 8 square plus 5 square. Then we simplify to get, so we simplify to get 8 over root of 89, 89 over root of 89, which can simply become square root of 89 when we rationalize. Now, what is now equation of a circle? That is x minus a square plus y minus b square equal to r square. A and b is now our center. That is s minus a. Our a is 1, the center of the circle. Y minus b, our b is 20, equal to r square. Our r square is, our r is square root of 89, then all square. Then we will simplify this. So I don't need to explain how this will become. Just expand this, this one will become 89. Then we bring it in. You are going to get this as your answer. This question as an assignment. In fact, the solution is here. I'm showing you the solution as well. This is the solution. That's the question. Find the value of k such that this line is a tangent to this circle. Hence, determine the point of contact for each values of k. You have solutions there. Let's consider another important concept. Look at this circle. This is a circle. This is point of contact of a tangent line. Let's have a tangent line here. This is center of the circle. Let's say the center of the circle is point A, B. We know that this is the radius of the circle. By circle theorem, we know that this place is 90 degrees. And let's say this is point S1, Y1. The question is that from this point of contact here, which is point S, Y, this one is S1, Y1. Can we know the length of this place? That is we call it tangent line. The length of the tangent line. This place is called length of the tangent line. From the point of contact. This point of contact to any point, let's say this point T equal to S1, Y1. So we have known the general form of a circle. The formula is very easy to prove. After using Pythagoras theorem and simplifying, you should have S1 square plus Y1 square plus 2GS1 plus 2FY1 plus C. So this is the formula. So it's very easy. So you only need to substitute the point inside the given equation of a circle. If you look at the example here, find the length of a tangent line to this circle drawn from the point of contact to this point. These are point S1. So our distance, the length of the tangent line will just be S. Anywhere you see S, put it as 3. Anywhere you see Y, put it as minus 2. So this will be 3 squared plus minus 2 squared plus 3 into 3 minus 5 into minus 2 plus 13. So that is just as simple as ABC. So this will give me 9 plus 4 plus 9 plus 10 plus 13, and that should give me 45. And the 9 times 5 is 45. This should be 3 root 5. 3 root 5. So this is the length of the tangent line from the point of contact to end to this point 3, 2. So let's have a good day. We'll meet in the next topic.